All right, so now I want to talk about the idea of scale in our scene and our simulation in general. If you've done any kind of simulation work, whether it's our the other volumes lessons or the liquids lessons, you know that by default the scene scale matters quite a bit. These numbers aren't just for show; they literally are how many meters the distance is. So the fluid dynamics work in a way that respect more or less that distance. So we need to make sure that when we draw distances out, let's say, like the boat goes from here to here over this many seconds, that it's not going like 100 miles in 5 seconds, or it's only going 5 feet in 5 seconds, but you expected more. Because again, the fluid will respond in that way. So along those lines, let's make a geometry node and bring a boat in. And that boat will be the boat. So put a file stop down. Wherever you copied your, well actually I don't think I did, so let's do that now. Here's the boat file, and then go find your project on Windows. I have it under my documents, Houdini projects, and then there it is, Fluids 3 Oceans with a capital C. And then put a folder in here. I'm going to call it model. Obviously you can be called whatever you want. And then I'm pasting my boat in there. So back to this. Go to job, there's model, and there's our boat. There it is. Facing the wrong direction for now because it is going to go this way. But in any case, scale-wise, if I middle click and hold, I can see how big it is. Along the z-axis, which is this axis, and if you ever forget, remember you can see it down here, this barely legible blue z. It's 12.7 meters long, so it's 36, 38 feet long. You know, pretty big boat for a power boat anyway, but nonetheless, there you go. And we now need to figure out, if you were drawing your own path, we need to figure it out. Now I just want to explain how I got to the length that this is. And I'll put a null in here too for out, because we will be asking for this boat in a few places later on for collisions. Now, how far should this path be? If our shot is 120 frames long, and we know that it's 24 frames per second, that's 5 seconds. 5 times 24 is 120. Now, let's say the boat's going to go at a speed of 30 knots. Now, 30 knots, apparently, it's about 35 miles per hour, and 30 knots is also apparently a pretty good speed for a power or speedboat. So 35 miles per hour. Now, miles per hour may not mean much to you, and it means even less here when we're dealing with meters. So 35 miles per hour is 57 kilometers per hour, give or take. So 57,000 meters. Okay, so now we're getting somewhere. We got meters here. Obviously 5 seconds is not an hour. So what fraction of an hour is 5 seconds? Well, 5 seconds is a 1/12 of a minute, and a minute is a 60th of an hour. So 1/12 times 1/60th is 1/720th. So 1/720th of 57,000 meters is about 79 meters. So when I drew this path, I made it that long. So it's about 79 meters, more or less. Obviously, it doesn't need to be exactly 30 knots, but it will be about that. Good. So now we need to actually have our boat follow this path. This will be the easiest thing you do in this entire lesson, probably, because we're going to use the shelf tools, and we don't usually use them. The constraints over here have some various ways to bind one thing's movement to another. We're going to use the follow path this time. Again, I don't usually use the shelf tools because I want you to understand how things work, and the shelf tools honestly don't always do it the best way. In this case, this is the most straightforward way of doing it, so we are going to do it in this manner. So click on the boat, click on follow path, and then follow the prompts on the bottom. Now select path object, so that's this one. Press enter. Now select look at object. If any, there's no look at object, it's just going to go, it's just going to, we just want to align itself to the path and not look at something else. Look up object, we don't need any, and that's it. And now our boat follows it. From the beginning of the shot, it starts at the beginning, and at the end of the shot, it's at the end of it. Now there's one little tweak we need to do, and that's to look at that constraint setup. So you can see now on our geometry node, Enable constraints is on. Obviously, you can turn it off. But it's on and is pointing to a CHOPS network, which is a channel operator. If you're not familiar with CHOPS, basically they are signal processing operators. And there it is in a CHOP network. That's why it looks like a little oscilloscope. And they do a whole bunch of stuff, but in Houdini in particular, they do various, again, constraints and transform related things. So what I want to change is where along the curve it thinks we are. It's actually pretty good already, but after the end of the shot and before the beginning of the shot, it will jump back. So if I go here, 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 on frame 121, it's going to pop back to here. Why does that matter? It can matter for motion blur calculations. It could matter for simulation stuff. If you have pre-roll, if you wanted to have the sim start before this frame, on frame 0, it's going to be here. So let's just avoid all of that and say the current frame divided by the last frame is a pretty good shot at this, but let's make sure that you're never below 0, which is interpreted as, again, flipping to the other side, and above 1, which is also interpreted as flipping to the other side. So just keep it from 0 to 1. You won't see any practical difference here, but just so you know, that's a common little gotcha. So let's just get that out of the way. Also take the opportunity to make these nodes green. I like any kind of helper geometry to look like this. And let's also make a red node, which is I reserve for our render nodes. What I mean by helper geometry is it doesn't get rendered. There are things that feed into other things that feed into other things. But ultimately, these nodes that I prefix as render underscore, which are still just geometry nodes, these will be the things that actually get rendered. Mostly for organization and mostly so you don't make weird mistakes. So let's go grab that boat. One of the reasons why we have these panes like this is I can just drag this to here, and it will put a reference to that. And I can see two boats. If I do hide other objects, now I just see the one boat, but it's not moving. We need to do into this object to actually make sure that it's getting the transform. Otherwise, it's just getting a non-moving boat at the origin, which is what this literally is. It's only moving because of the transform above it. So you gotta do into this object. And there you go. So we got a moving boat. I wanna give it some motion blur. So I don't usually put extra nodes in my render thing here, but I'm going to make an exception this time. There we go. Now we have some velocity vectors on it by clicking on this. And there you go. Now we got a nice render boat. So that's what's actually going to be rendered later on. And along those lines, just for fun, let's give it a material now before we even get to the rendering stuff. That'll just be nice to look at. So when this lesson was recorded, we're still very much using Mantra. Karma's not quite ready yet. You know, whatever material thing comes down the pipe, do that later. Again, this is arbitrary anyway. I'm going to choose oxidized steel for our example. And then I'm going to go to the render on the boat, choose oxidized steel. And, oh, I still have this boat visual. There we go. Now I can see it, gray. Click on this to go to it. I'm going to click on the color, go to this kind of middle orange one here. And maybe I'll make it a little bit lighter also, a little shinier. So probably end up looking more yellow in my experience once there's actual like light on it. But in the viewport here, it looks a little bit more orange. There you go. So we've got a boat thing and we're ready to move on.